should I present my screen?
That's correct. Yes, please share your screen.
Okay. Can everybody see this?
Yep.
Okay, cool. Let's go ahead and get started. So first off, thank you for joining this talk. Today we're going to talk about the hardware management module sub-project for OCP. In a nutshell, this is really a smarter, simpler, open approach to out-of-band management for servers. The agenda, I'm going to give just a quick background on BMCs, just a little tiny primer there. We're going to cover the charter, why we decided to create a hardware management module subgroup. We're going to talk about some of the products available in the OCP marketplace right now, and we'll jump into the call to action and next steps here. So what is a BMC? A baseboard management controller, or BMC, is really a small computer that sits on virtually every server motherboard that's out there right now. There's I think a great analogy to use is, I'm going to borrow this analogy by Jessie Frizzell, who put this, she did a great ACM article about BMCs, and I'm going to quote this: if the CPU is the brain of the board, then the BMC is really the brain stem. And I think that's a great analogy to use for, what is a BMC. So diving in there a little bit deeper, why do we need BMCs? What do they do? BMCs perform a range of telemetry on servers, like checking temperature ranges, voltages, current, and other kinds of health checks. Admins typically monitor these stats through IPMI or Redfish, issuing commands through a network topology that's separate and insulated from the communication between the server CPU, firmware, and operating system. For the most part, that's true. They're very underrated. The uptime for these is close to 100%. In theory, if your BMC is not working, and your server goes down, you're definitely going to notice. So the expectation is for these guys to be on 24/7. Please no downtime. They're really a critical subsystem part of a server design. Just making sure everybody can see my screen here is because I'm on the audio. BMCs, we have a problem. Making sure I'm up to date here. We're on this slide.
Yep.
Okay. So I've been working on BMCs for the last decade or so. It's amazing to think I've been doing this for 10 years. Let me take you on a quick tour of some of the approaches I've seen. There's usually two buckets. The first bucket is the module approach. A lot of different hardware providers have gone down this route. Every major OEM or ODM has tried to solve standardizing the BMC for their product lineup. And I've been asking myself about 2 years ago or so, there must be a good reason why vendors are taking this approach. And let's jump in to the second approach. The second bucket here is what I call just on the board approach. And there's plenty of reasons to do this, like cost, for example. Maybe you have no choice due to board real estate and you have to slap this on the PCB. Or maybe you just really, really dislike modules. A lot of different reasons why you would do this. I've done this myself in my career many times. And one of the things that can happen from a code perspective, I'm just using this as an example here, very specific, is This actually trickles down to code when you have all these different types of either modules or BMCs in different PCB layouts. It trickles down to code. Next thing you have is a bunch of platform-specific code hacks to make this work, usually more than you anticipate. Some good examples I've done in my past are things like platform-specific clock delays, strap overrides, or simply because you used RGMI port 0 instead of port 1. Those, the typical, right? But now what you've done is you've created somewhat of a silo. Other EEs from other orgs can't reuse your design that easily. They can't make it better next time. And trust me, they typically just end up doing it themselves, whoever's the lead EE on the project, and the cycle kind of continues. So why standardize? The first is the collaboration aspect. You don't have these silos anymore, right? Everybody can contribute, anyone can use. You can reiterate on the last product. You can use this across multiple different platforms in your product lineup. You don't have these silos anymore. You can get faster code development. Like instead of you can use a BringUp vehicle to start your dev work for the BMC instead of waiting for tape out, for the first tape out for your server platform that you're designing. You should see some velocity increase from that. Yeah, you get a much longer life. Instead of having a single BMC that's just specific to one generation of hardware, now you can reuse this in your roadmap. You can actually get a multi-generation support for your servers and network designs. And if security is top of mind for you, you can really focus all your efforts on a single hardened BMC for your company. But there's lots of good reasons to standardize here. So addressing these problems and seeing all the benefits for standardization, we decided to create a sub-project. The charter basically will give designers the option to standardize their BMCs in a nutshell. Again, this is a sub-project under hardware management track, and there's currently 2 active work streams going on. One is the RunBMC specification. That's a RunBMC work stream. There's a specification that was published in August 2019. There's a kind of a work in progress DC SEM specification. Is currently a work in progress of being submitted. These are the 2 main work streams that are going on right now, and I'm going to focus the next couple of slides just talking about the progress on RunBMC. So the RunBMC specification, really the big picture here is the goal is to provide a designer all the functionality you need for a server network design. You get all of this over a 260-pin connector. The connector is a DDR4 SODIMM JEDEC form factor connector. And we think this is good enough for 99% of the use cases we've seen out there from all of our studies and from our talks with everybody in the community. Again, this specification is published. I have a link at the end, and it's available to designers right now to use. And there's a wall of text up here, but the most important things is the spec provides everything from host management to various GPIOs to use over this 260-pin physical edge connector. Yeah, we do have a product lineup. We've been working with partners and community members, and we actually have some products on the OCP marketplace right now. I'm going to give a brief overview of each of these in the next couple of slides. The first 3 from the left to the right are products that abide to the RunBMC specification. And the last product I'm showing here is the BringUp Vehicle. It's that we can use this BringUp vehicle to do lightweight development on these daughter boards. And let's jump into the first module that's on the OCP marketplace. This is the RunBMC HS2500. It uses the AST2500 from ASpeed, has a 1 gig PHY. It has two 32 megabytes of SPI flash. It has 512 megabytes of DDR4, a temp sensor and EEPROM. This is in a 32 millimeter height design. So this is really nice because you can fit this vertically in a 1U or 10U form factor. This, boots OpenBMC. We've done some platform specific code here to get this booted. Provides full specification functionality. We partnered with Hive Design Solutions, and there's a link here. It's available on the OCP marketplace right now. Next slide here. This is the RunBMC MPC M7. This was a co-development effort with Nuvoton. This is using their SoC lineup product called the MPC M7. This is used in some server platforms right now, this SoC. Again, has a 1 gig PHY on board. It has a little bit more flash than the ASpeed one. It has 512 megabytes of DDR4. And on the bottom of this PCB is an optional stuff, no stuff eMMC that you can use if you need more storage. This is a 50 millimeter design. So this can fit right angle in a 1OU, 1RU form factor, or vertical in a 2OU, 2RU server design, network design. Intel has designed a prototype based on the Cyclone B FPGA. And this prototype supports, again, the OpenBMC code stack. It really has a focus on security. So they had a demo for last OCP for platform firmware resilience, and you can also do custom implementations for root of trust. It can support partition systems or accelerator sleds, and this one's a work in progress. Still have some steps before we're going to contribute this to OCP. It's all currently an active swim lane here. And the last product that we have is the BringUp Vehicle. We've used this for code development on ASpeed and Nuvoton designs. On the left, you have the Nuvoton design, and on the same BringUp board, you have the ASpeed design on the same board. And you can basically think of the BringUp Vehicle as a big breakout board, right? It's been really handy to use because you don't need an actual server to perform your development. You can just use this BringUp Vehicle on your desk or in the lab. It's pretty lightweight, and it can support, the intent is to support any RunBMC board. You can do development using this BringUp vehicle board and test all the functionality with all these nice breakouts. So what's next? A couple of things that we're working on. One is we're evaluating a RunBMC module based on the AST2600. We've done some preliminary study on what this module would look like. One of the key differences from a physical perspective, really the move from the 2500 to the 2600, it's a little bigger footprint, so we think we're going to need a 50 millimeter height RunBMC daughter board in order to fit this in all the components. We are also working on the next version of the spec, version 2.0. We've received a lot of feedback from our partners and community members. We're going to make sure we have backwards compatibility, of course, with v1.4. There's some clarity in v2.0 and some things like I3C that we need to incorporate into the spec. So we're actively working on that. We're partnering with DC. So the work stream I alluded to earlier, the DC SEM, that's we're working with that team to submit that to OCP, and we're collecting requirements for future designs for OCP Marketplace. So really, the call to action here is, feel free to reach out to me, or Jared, or I think we're going to have an additional sub-project lead here that's not listed here. I'll make sure to update this. But feel free to join the subgroup in OCP, help provide feedback on specifications such as RunBMC and DC SEM. And if you're looking to find any additional information, there's some links here as well. That being said, I blew through this pretty quickly. So now, we can open the floor up for any questions.
So this is John. So are there project meetings for this sub-project where one could provide feedback on OpenBMC or RunBMC spec?
Yeah, hey, John, thanks for asking this. We have not set any up yet, but we're hoping to set one up this month. We're a little behind there in that aspect. I've seen some threads going, but that's on the top of my list here. So not yet, but we do have a mailing list that people can join and provide the best time that works for them to set up a monthly cadence here.
Right, because you mentioned RunBMC 2.0, and based on OCP rules, that should really be done out in public in a meeting.
Yep. Yeah, thanks. We'll make sure to make this all public. A lot of this is just receiving feedback through emails right now, but we need to, I do have an AI here to make this all public and update the Twiki of all the feedback.
So do you know what type of other changes might be added to 2.0? Or is that something you can discuss?
Yeah, Jared, do you want to talk about this?
So looking into future-proofing RunBMC would be including I3C for platform compatibility with DDR5. We've seen that that's going to be the interface for talking to the low-level the DIM module, as far as putting out the DMID code output. And then we are going to be making an addition to add in not just the normal system reset, but also the core reset. So those would be inputs to the RunBMC that modern BMC chips have, one way to reset the entire chip with the peripherals and one way to just reset the core of the chip. And then I think these two efforts that I mentioned, and then maybe one other effort kind of clearing up, adding EMMC as a feature and how that would be done. Since we've seen a lot of demand for that feature specifically on modules to support eMMC. So those are the top three, and then we're inviting the discussion for anybody else who has ideas about features they would want to add. One thing I also should mention is making sure that we build in robust, platform resilience or root of trust into the specification for people who want to add security-based features.
So besides the security features, the looks like the update to 2.0 will be fairly minor.
It should be minor, and making sure that we have backwards compatibility to the currently released version is, the utmost importance. So we're starting to think about that as well. But yes, they won't be major changes as far as we know, but we're inviting people to join the discussion if people have big ideas about what could be added here.
So you expect a 2.0 would fit in the same DIM connector, pinned
Yes.
out the same way?
Yes, and if it doesn't, we failed, so it should.
Awesome.
Yeah.
And I know this is early, but do you have a timeline as to when 2.0 might be out?
Yeah, so I think what we'd like to do is have at least a rough draft to present for OCP in next year, which would give us about 4 months to have some good discussion before, you know, having a draft to create a good discussion in OCP next year. And then what I would like to see, and I think Eric as well, is that we publish 2.0 2 years after the 1.4 specification. So I would say that our end date should be August of next year.
Oh, right before OCP Summit.
Yep, right.
We did get a couple of questions. Are you ready for a couple of questions from the comments box?
Sure.
The first
Yeah.
one is from Ryan Weiss. What are the key differences between DCSCM and RunBMC? Why two?
Eric, you want to take this one?
John, I might need to pass this on to John.
Yeah, why don't you?
Because we've had some great discussion here.
Okay, so there were two ongoing efforts. DCSCM was actually started in the server project, and RunBMC had already started in the hardware management project. And the reason that we created one project was so we wouldn't confuse the community about both of these modular BMC projects being in two separate projects. At this point, from a progress standpoint, as Eric mentioned, RunBMC has already been submitted, and there are already products in the marketplace. DCSCM has been worked on, but has not been submitted. So from the standpoint of OCP, can we really go talk about it if it hasn't been submitted into a community forum where we can have that discussion? Okay. That said, both of them are modular BMCs. SCM has the root of trust on it in addition as part of its original design. RunBMC is, as just mentioned earlier, is looking at putting its root of trust on the RunBMC module. So these things are really converging quickly as to what type of functionalities will be on it. The main distinction is the RunBMC's connector, which is an SODIMM, which has I believe, a lot more pinouts than DCSCM. DCM is based on the same, it's an SFF connector, the same one used, I think, for the NIC 3.0. And so that's why we're anxious on having it arrive. It has, I believe, fewer pins than SODIMM, and so one of the things is to actually get DCSCM in, have it finalized, have it released, and then have products appear on the marketplace. Does that answer your question?
I think it does, yeah. So
Okay.
Great, thank you. There's one other question. Does the RunBMC implementation on AST2500 support AMD EPYC family processors?
So does it support EPYC, the new platform? Yeah, so we took a close look at OCP designs before designing RunBMC. So I firmly believe that you will have all the compatibility, and we're actually doing some studies with an ODM to see if we can fit in RunBMC on an EPYC platform. And we have all the available signals. So it's definitely possible to engineer for compatibility with AMD platforms.
Okay, great, thanks. I think that's all the questions that we have so far.
Oh, great.
So Hamal, do you want to get ready for the next one in just a couple minutes?
Yes.
Thank you, everybody.
Thanks.
Thank you, OCP.
Great job. Thank you.
Back to you, Bob. I think we have, what, 4 minutes before we start the next session?
Yes.
About 3 minutes. Remember, we're there's a little delay.
Yeah.
Okay. We're gonna drink some water.
And then Himal, are you going to project the slides?
Yes, I'll project the slide.
All right, then we'll just give you a cue for turning pages when needed.
Yeah, we're doing great on time. We're staying right on schedule. So great job.
Yeah, thanks, Dirk. Yes, thanks for your support. Session is going smooth so far.